welcome back everybody to another exciting Duckman production. I'm your host, the Duckman himself. Haha! Well, if you didn't see already from the thumbnail and the video title, yes, this is an Eleanore video, but it's not Eleanore in the same sense because I can't take her out of the garage because it's about to start raining. It's probably going to rain for about the next week. We have a hurricane, well, it's not a hurricane yet, but it's a hurricane coming in our general direction, kind of through Louisiana, which is not where I want to see it because when it goes west of me is usually when I get the worst of it. So here's hoping it's not going to be too bad, but I'm going to be trapped inside for a while, which means I need to be doing some inside video stuff, and that means I'll be doing some programming and soldering together Eleanor's circuit boards. That's right, we got Eleanor's computer stuff together here today. So we're going to open up this box, go through it. I'm going to start putting these boards together, start getting them tested, and hopefully by the end of this video, the hurricane will long since been over. I'll still be alive, and if you're watching this video, it's probably true. And hopefully we have something that we can test and try. So anyway, with that said, like, comment, and subscribe. Don't forget to plug the link below to get updates every time I have a video. Check out duckshit.net for all my different social media links. And we'll be back right after that intro. Alright, this is exciting. At least it's exciting for me anyway. This is my, switches that I'm going to be using in Eleanore, these beautiful, nice stainless steel switches, and they light up. I 3D printed a custom socket on here, and yes, this is important to the video. I couldn't find a socket that fits on these switches because they're very non-standard. They're specific only to this manufacturer. So I found some off-the-shelf clips and pins that plug into the backside of this here. I 3D printed a socket to make sure my spacing was correct, and then I literally assembled it. And then using the CAD drawing that I made with that, I then turned that into a circuit board with my entire switch array on it. So inside here, we have us this looks like, and it's the only green board that I got, my fuse box. Yeah, this is what's going to become my fuse box. Get all those connections I need to solder. All the fuse arrays on here. I believe there was something like 32 or 34 fuses that I set up on there. There's also a bunch of test lights and a few other things that makes it look cool when it's in operation. So that's the fuse box. Here is, looks like the motherboard. Oh, looks like it's already starting to tear. Good news. Okay. There's the motherboard itself. This is what controls everything else. So this will essentially come out to send signals to the relay board. This relay board is a really standard off-the-shelf component that you can buy just about anywhere. They're not too expensive. Actually, you can get these cheaper than I can make them for, so it made no sense to reinvent the wheel and do my own. But my board is supposed to be the same size as that one, and it looks like I nailed it. Even the little screw holes are lining up, so this should mount using the same fixture. So any 3D printed model or any rail that this is intended to mount on, my board should fit the same way. And that was important to me because, well, I wanted everything to fit together and nice and organized. So these boards are all the same size, as you can see. So there's our motherboard. Here's the individual shift register components on it. If you don't know what a shift register is, you might want to go back to the other video where I talked about it. It's the same chip, well, not exactly the same chip, but it functions just like the NES controllers of the past. Literally, every time you push a button, it reads all the buttons at once and then sends a signal back to the control unit, and then the computer then interprets what's being pushed. But this is essentially the same thing, except I use multiple chips all the way across it. 4 chips for the outs, 4 chips for the ins. It gives me 32 inputs, and it gives me 32 outputs. So with that said, that's going to go with that. That's why we have 32 fuses. That works with that. Now, I did have to order multiples of these boards. I couldn't get just one. That's just the way they work. They ship in bulk. So, it looks like this one's starting to peel open also. I like that they vacuum packed everything. It's just they sucked it too hard, I guess, and it split open. That sounds like a bad date night. This is my switch panel. This is the one that I've been working on extra on top of everything else. These the little CAD drawings that went for this socket I made in here. So this way I have my 8 switches that goes all the way across. So the nice stainless steel switchboard that you saw, that I had, again, cut by a machinist that actually laser cut everything out of it. These switches should go into this panel, and because this is all socketed, these switches will unplug, so if one goes bad, I can easily replace it. The idea behind this is that it can be serviceable while you're on the road, with just a pocket full of components, so if something breaks, it's all off the shelf and easy to use stuff. This uses another 4 chips, 1 for inputs and 3 for outputs. It's because each one of these little buttons is an LGBT button. It lights up 3 different colors, and it gives me a nice rainbow effect on here should I choose to do it. So again, by the time we get to the end of this video, hopefully these things will be functioning. I'm going to start soldering these things together. These, I think I've been working on this since I started coding it in somewhere around 2017, 2018, so this is about 6 years in the making. I started working on these boards about a year ago, and it's amazing to see these things actually in my hands. This is what I produced. Now, I used to etch my own boards, but I can't get this level of detail and nothing that looks this nice. This is professional grade stuff, like something you'd find in the consumer electronics. This is really, really nice stuff. And if this all functions the way it's supposed to, I may put these up for sale, but anybody that's been asking me about it, how much it's going to cost, I assure you, it won't be cheap. And it's not because the hardware is not cheap, it's because it's going to come with an array of support. Just because if anything goes wrong with it, you guys are going to be pissed off to the end if it doesn't work right. So I need to be there to back my product, and well, that's essentially the plan. Well, anyway, this is the switchboard, and because I built the motherboards here with the expandability, I actually have expandability sockets on it. You can actually use a second motherboard to expand because it'll daisy chain to the next motherboard. I mean, I thought way ahead on this stuff. And this, well, I sent one flying, so much for that. That's going to be my defect, right? So, this is the expansion board that I designed, essentially, because this was all ready to go, that I just built this to add on to it. And it was just a matter of hooking up some ribbon cables to it. You'll see. This is all going to be soldered together. I'm just going to start assembling and stuff. I'm so excited. You can't tell already. I'm so excited. There's been so much time into sitting behind a desk and you know, it's ticking away on the computer and tracing things back together and making things physically fit, because this, again, it's all CAD and everything's evenly spaced, and it needed to fit with the Eleanore, so that way where I want to put the holes in the body, everything had to line up perfectly. And there was a lot of work that went into this, more than I put into most other things. A lot of things when it comes to my machining or even building cars, you just start, you know, adjusting, take off a little bit of metal at a time till it fits. This is so precision, it's down to the 100th of a millimeter. I mean, even smaller than that even in some cases. Some of these things are yeah, anyway. I think I'm rattling on enough. So let's start soldering on this stuff. Let's see if we can get something functional. Hopefully during the week, during this hurricane, I won't be losing power, and, you know, I won't be losing my life, or my house, or my roof, or, you know, my cars, or my birds, or, you know, whatever we got. It'd be a really, really bad week if that were to happen. But anyway, wish me the best, guys. All right, well, let's go ahead and hop to it, and we'll see what turns out. So thanks for watching. And yes, this is an electrical video with more electronics and stuff like that, which, if it's not your flavor, then exit now.
1 week later.
Alright, well, we're back after an amazing and really unrealistic amount of technical difficulties in this video production. So how did I do? Well, here's a circuit board, all soldered together, as you can see. Let me turn the microphone around so you guys can hear me a little bit better. There we go. So here's the motherboard with all the chips soldered down onto it. Here's my computer. There's all the components that make it work. Ultra-fine ribbon cables connect everything together. This is an off-the-shelf relay board. These are pretty readily available. Remember, I made these the same size. Did that on purpose, so that way everything is universally mounted. Whatever people have made for this will work for my boards, too. And then here's my control board. This is an afterthought. I wanted something that had nice buttons and nice switches to add to the car. It's a complement to the stock switches and stuff that'll be on the car as well. So I put this together. There's the board with all the chips soldered down onto it. And here's the stainless steel switches that you've seen before. Now, does everything work? Yes, it does work. But it's not without its problems and difficulties. There's a few things that I had a little oversight and I missed out on that I just didn't do properly. And in fact, I chose the wrong chipset for the output chips to go to the relays. And how do I know that? The moment I powered it on, and the relay board lit up like that. Now, that may not seem like a problem to you, but what happens when you, let's say, turn your key on? Do you want every single thing on the car to come on at the same time? I don't. I don't want anything to come on except for what I programmed. Unfortunately, the way that these chips work and what this board needs to receive as a signal to activate these relays are opposites. So in other words, these things switch to high when they're either activated in the on mode, or if they're, well, in this case, the computer's not even booted up yet at all. What I'm trying to get out here, and I'm not quite clear, is that the relays are going to fail into the on position because that's the way these chips work. And that's a big no-no because if the computer is off for any reason at all, but the relay board has power, then that means every option in the car is going to come on at exactly the same time. And that's a big no-no. They need to be failed off, not on. Gotta fix that. I can force everything into low mode, which will shut the relays off as soon as the computer boots up. All I gotta do is plug that in. There it goes. The computer boots up that fast. I mean, literally, that fast. That's how fast everything comes up on this, which is remarkable, because it gives you enough time to sit down in the seat of your car and push a button if I want to do it that way, or if I want to put a transponder in my pocket, or if I want to wave a transponder near the dashboard, or if I want to have some kind of transponder for proximity sensor so as I near the car it can wake up, or if I want to wake it up from my phone or tablet. There's options for that too, and it wakes up fast, really, really fast. And immediately I can start pushing buttons on it. And that button, as you see, it is flashing. I did program it to do that. Simple touch again, it goes back off. And we'll just start down on the board here. And I've got these things randomly programmed for a bunch of different colors. And it's only because I have them programmed that way. Of course, each switch is capable of any color of the LGBT spectrum, or white, or off. It'll do that too. Here we go. Now, these last two are programmed to do something a little bit differently. If I push it right now, it does absolutely nothing. And the reason for that is because this switch is the master. And again, these switches can be used in different orders or different combinations. Whatever I program that this little computer to do, these switches will handle and then send the signals or whatever interpretation that I want off to the relay board. So let's say I want to have every single button pushed on this thing at exactly the same time. It makes the horn. That's silly, but it's possible. Or maybe I just want to do the first two. Maybe I want to push this one, wait 2 seconds, then push that one. Maybe I want to double tap that one. Maybe I want to push and hold this one. There's a lot of different options that I have here, and in fact, I probably didn't need 8 switches, but I got that many because I think it looks cool. I probably could have pulled this off with just 4, maybe even as little as 3. But again, these 2 buttons are programmed to do things, but they're not doing anything right now because this switch is not on. So what we'll do is we'll turn that switch on next, and it'll start flashing like it's supposed to. Now we'll turn this one off. We'll turn this one off. And now we're going to push that button. Because this one is now enabled, this button in the on position is now going to do something different. There it is. That is a relay demo mode that I coded into the programming on this. There's also a second relay demo mode that I put into this button. Now, of course, I can turn on anything that I want in any order that I want, or for as long as I want, for any interval. Want something on just for just a second? I could have it on for a second. If I want it on for 10 milliseconds, that's doable too. If I want the thing to stay on permanently until a button is pushed again, I can do that. If I want it just to come on when I'm pressing and holding a button, it can do that. If I want it to come on only after I've held the button for 2 seconds, I can do that. This thing has an unlimited amount of programmability in it, and there's really not too much to it. And I'm just overjoyed with everything on this, that it works this great. One more feature I built into this. Push and hold, everything turns white, with exception of that, because of course I have that one programmed to flash. And then of course if I just want to turn everything off, press and hold that and it's off. And again, that one's programmed to stay on and flash until I touch it. So it works that way, but press and hold for 2 seconds makes it do things. Now if I press and hold for 2 seconds, everything once again is lit up. And then this circuit board over here, which is, well, it's just a breadboard, this is where I started to build in a PWM dimmer. If you're not familiar with what PWM is, it's called pulse width modulation. And what it is it alternates between a cycle of on versus off. The more on cycle you have, the brighter the LEDs would be in this case, or if you're using an electric motor, the faster the motor would turn. At the lower the PWM duty cycle, the dimmer they would be. And this is a PWM generator, and into this board I built a PWM receiver receptacle for it, because I thought ahead on it, and it allows me to turn a knob and dim the LEDs. That simple. Now, some folks were concerned, hey, Duckman, when you turn on your headlights, these things are going to be blinding. And truthfully, I think they're very subdued. They're bright enough to see in daylight. I mean, we're outside right now. But at the same time, when you see them at night, and one of my failed videos, actually I was recording at night, I didn't realize it was quite as dark as it was. The lights lit up good, and you'll see a little bit of the footage here in this video, but the bad thing is you couldn't really see the circuit boards or anything else around it. But built into this computer is also a PWM line, so if I turn on the headlights, I can program it to automatically dim these things by 50%, or 25%, or 75%, whatever I decide to set them at. Or, I mean, if I want to be a complete psycho, I can make them go brighter if the headlights are turned on. That's possible too. But this is a master override and allows me to dim or brighten the lights based on a knob, which I can just install up underneath the dashboard, someplace inconspicuous. So I am just very, very happy that everything's working here. I have a couple more boards that I need to finish soldering, one of which is my fuse box, which really has not very much to it. It's real simple because it's just a little blade connector, just like you see on Volkswagen wiring. A little blade connector that goes to in, and then it has wiring which goes back to the relay to out. I probably said that backwards. Relay would then go out to the fuse box and then out to the devices. These also would have blade styles like this, soldered onto here. But I haven't gotten that far yet because I didn't know if this board was going to be right. And we already know that I have the wrong chipset on it based on the behaviors that it does here. See what I mean? If I turn the computer off, all the relays come on. So that's not going to work. Not going to work at all. I need to actually get a different set of chips put onto this board, but you can't just flip the chips out because they use a completely different pinout. So that means this board is actually going to have to go into the hopper. This one's no good. I have to essentially redevelop a board using different chips, and the chips in question are actually the ones that I'm using on here. These are the correct ones. These will switch to ground normally, so in other words, when I pull the power out of this thing, these things should not come on and should not do any of that crazy flashing stuff to the relay, so everything should stay nice and off. You see what I mean? That stays off, this thing comes on, so that solves that problem. So we shouldn't have any issues like that. And see, again, when I plugged the computer back into it, it didn't flash. That's what we need this to do. So I'll be switching out this style chips that are on here. These are shift registers. Into these sockets here, I'll just do a brand new schematic for a new board, and I'll have that printed and sent out. Now, these things weren't too awfully expensive, but a lot of folks have been asking, hey, Duckman, you know, can I get myself a copy of these? And I say, yeah, I'd like to do that for you, but I guarantee you it's not going to be cheap. It won't be cheap. And I've already had some people on YouTube, Duckman, you need to stop using social media to line your pockets. I'm not using it to line my pockets. This is my job, guys. This is my livelihood. This is what I do and why I quit my day job. I enjoy building things on social media. I enjoy getting checks from YouTube every month. Do people send me donations? Not really. I mean, I do have a Patreon page, and there's some money that comes in through that. But, I mean, we're talking $50 a month, guys. That's it. That's it. If you want to support me on Patreon, head over there. If you sign up for just like the $1 package, though, I think I get like 20 cents out of it. Everybody gobbles it up. If you really want to help me out, you're probably going to have to push for $2 or $5. If you could do better than that, that'd be great. But I'm not asking for that. And you notice I probably haven't really mentioned my Patreon really much in years, just because I don't. And I'm going to kick that rooster's ass if he doesn't shut up. But he hears my voice, so he's going nuts. This is what he does. So anyway, we're going to have these reprinted. We're going to finish up the circuit boards for the fuse box, which I think are right. I don't think I'm going to have to redo those. Another technical difficulty also was on this, I noticed. These things are numbered out of order. Number 1 is here, number 8 is there. And the reason why that is because when I built the boards, I programmed them this way. So number 1 is here, number 8 is there. So that makes it a little obnoxious when I actually do the software encoding for this, because I need to label everything and read a book, because it's confusing. It's easy to do backwards. Not a big deal, just kind of a nuisance thing. In addition to that, these chips are also in here wrong. When I read the manual, and this is something that Duckman likes to do, I like to read the manual and learn how these things work before I commit to anything. And in this case, these input chips, which is where the switches would go into on these boards, these chips need to be put in backwards because their signals are going into the computer versus something that comes out. So the linear path of these, again, is reversed. That's the theory anyway, and that's what the manual told me to do. Well, the problem is, this is the last chip in the line, or I should say the first. This is switch number 1 here. So number 1 is here all the way through 8, and then you go to the next one here, and this is 9 through 16. Obnoxious. Again, I need a book that I have to write down a list and have everything numbered in such a way so that way I can code for this. Friggin' obnoxious. I've already solved this. I've already reprogrammed this board, and the only thing I did, I left the chips where they're at. I just reconnected them on the board, you know, with the wiring the traces on it, if you want to get a good look at it. Here's some of the traces on the board. Probably camera can't even pick that up. These boards are just so beautiful. These things were so well done. I'm just so happy with the way these turned out. But anyway, I'll finish all the soldering on these things later. I didn't want to get into that because that's a lot of soldering, and I didn't know if all these things were going to work. I did have a little test wire here, though, so that way I can touch the pins. All these switches go to ground. I kept everything simple. So if you hook up one of these systems in your vehicle, your switch goes to one of these pins and then to ground. It doesn't go to a power source. It doesn't go through a fuse. It doesn't need one. We're talking milliamps and 5 volts. So in the event something gets shorted out, what does it do? It turns on. It doesn't burn wires. It's actually what it was intended to do, to receive a computerized digital signal through your switch. Now, because there's only milliamps going through these switches also, so any of your stock switches that you have on the car that you want to use, or even if you pick up some switches out of your toolbox that you bought at Radio Shack 30 years ago, they'll also work just fine on this. You do not need a high amp fuse for anything, not even your headlights, because everything operates now through relays. So, switches work from chip to ground, simple. Okay, everything that works out of the relays will be going to devices. So it goes to a fuse, then to your headlight, to a fuse to your taillight, fuse to your turn signal, yada, yada, yada. In addition to that, the last thing, and I get criticized for this too, there are so many folks on the internet that told me, Duckman, toss the switches, old technology, go with a touchscreen. That's great, guys. What happens when your touchscreen fails? What happens when your touchscreen battery dies? What happens when you can't get your computer to fire up for some reason to think it's bricked? Now you can't drive home? Stupid! Besides, then the car doesn't look factory, and the idea behind this was to make it look retro, something from the period, even though that wouldn't technically be on a 56 Beetle. I wanted something that resembled, something like it was from the time period, and that's why I put switches. But touchscreen was always in the plan, guys, and I built this as far back as 2016, maybe it was 2018, I think it was. That's when I started doing the programming on this. Now, this sucker does work. If I push headlights on, and I might have to double tap it because currently the touchscreen and the switchboard do not sync up. I need to get these things to talk to each other in the code. There's 2 separate sections in the code for that, and they don't talk to each other. I just need to simply set a variable when one flips on and one flips off, so that way that's not an issue. So sometimes it takes a double tap to make the headlights come on. In this case, they're not coming on at all, and I don't even know why. Alright, I almost forgot. That switch is the one that enables everything. Remember these 2 buttons we said that did not function unless that was on? That's the case here. So if we want to turn this thing on, push headlights on, we do still have to double tap it. We do have to tap headlights on. There they are. We want to turn the headlights back off. They go off. Do the same with the high beams. There they are. And turn taillights on. There you go. Let's do taillights off. Let's do hazards. There you go. Left and right are both flashing. Turn the hazards back off. Let's do the left flasher. There's the left. And if I hit the right one, it should alternate to the other side. And it did. Canceled one, flipped the other. Turn the hazards back on. Hazards off. Turn our fuel pump on. There's the fuel pump. There's the ignition, and I'm going to call that coil instead. Very specifically, it's not the ignition, because when you think ignition, you might think, turning like a key, the ignition switch. In this case, it's going to be ignition as in ignition coil. So I'm going to very specifically relabel that. But this does function. If we come through here and we turn everything on also, and we're going to do that just for grins here. We're going to run it through a demo, and I don't want to demo it. Okay, one more button press in just a second here. But while we're waiting on that to catch up with itself, let's start turning on headlights. That thing runs on a delay. I gotta wait for it to finish its process. Here we go. Taillights on, hazards on, ignition on, fuel pump on, ignition on. Alright, everything's currently lit up. Everything's going crazy. I left that one off on purpose because we don't need to run that demo. But if everything was going nuts for some reason, there is a kill-all. Helps if I push it right. There it goes. Everything's off. Kills everything. So in the event there's a runaway failure, something goes nuts, electrical fire, a crash, God forbid there's a crash, everything can be shut off by way of either a single button press or some kind of a sensor. Everything could just be turned off completely. So, great benefit that I built that in there. But one gotcha, again, because this thing is forcing these things to go into a low value to shut these relays off, if I hit the kill, you see what happens here? Everything flashes, even if only for milliseconds. The fact is, it's doing what it's doing, and that could cause your horn to beep, cause your starter motor to engage. It can do all kinds of things, even if only for a second. We don't need that. We need to stop that. We need to turn that off. So again, getting new chips in here should solve that problem. Well, I think that just about covers this thing. A huge success on this stuff, the fact that it does work, and I've been able to get around the minor inconveniences of some of the things being labeled incorrectly, numbered incorrectly, and the fact that I have the wrong chips in it. I still got it working. The next revision, however, is going to solve a lot of these problems, and I'm so happy. I can't tell you how happy I am. You can probably hear it in my voice. I'm really, really excited to see this thing working. And I wish them f***ing roosters would shut up. They're the one thing that's driving me nuts right now because I'm just so happy with this, and they are just so irritating. I tried to get this thing recorded this morning when I had the girls outside because they're not nearly as noisy, and then it rained. This is, like I said, the 7th time that I've tried to cut this video since last weekend. 7 times, and it rained multiple times. I had a failure here, which is why I put paper underneath these things. So it turns out this tray, for some reason, affects how the boards operate, which was really, really weird. There's nothing conductive on it that I could see. It must be causing some kind of a capacitance, which I couldn't figure out. But as soon as I put the paper underneath it, problem was solved. I also had a problem with the camera losing audio for some reason. The audio was plugged in, the microphone was turned on, everything was fully functional. But damn it if I didn't lose the video, and that was the video I was happiest with. I even liked it better than this one. But anyway, I guess it's just going to be what it is. Alright, well, I guess it's about to wrap this thing up. We're going to call this done for the day. I'm going to start reprogramming these boards. Eleanor's circuit boards probably won't make it to the car show. Well, not the finished ones anyway. These might. Our car show is about 1 month from today. I have to check the calendar to see what the date is. Our show is on October 19th, and I think I'm releasing this video on the 18th or 19th. I can't remember which. Gotta look at the calendar. But it's 1 month from today, about when you're watching this. So, I'm hitting the high gear, trying to put as much as I can together on the car. Just like last year. It seems like I always wait until the last minute to do the most stuff. But this winter, I'm going to try to put a bigger push on Eleanore. I really want to see it done. The last couple of years, I don't know, I guess I've been in a little bit of a creative funk. I'm really afraid to damage and scratch the car, and I've been working on everybody else's stuff instead. But I want to change that up. I think we need a little more Eleanore. And I think you guys want a little more Eleanore in your lives. And boy, I still hate that name. And coincidentally, by the way, the rain that we had last week, which gave me the time to work on soldering these boards and getting everything tested, was because of a hurricane named Francine. And the coincidence of that is Eleanor's original name was Francine. I just figured, you know, what the hell are the chances of that? Anyway, her name wasn't that for but even a month when I had to dump my ex-girlfriend at the time. She didn't like the car, and she was just really giving me a hard time and belittling me and just being a complete ass about the car. So the car became my other woman, and in Miami slang from the 90s, one of the terms you would call your side chick is your Eleanore. So that's how she got her name. And of course I gave it the unique spelling with the extra letters in it to make it different from other vehicles that may have such similar names. But to be confused with a Mustang? Come on, guys, really? Alright, I guess that's it for now. So, like, comment, and subscribe. Don't forget to plug that dingle bell so you get updates every time I upload a video. Check out Duck on there for all my different social media links. And we'll see you on the next go-round. Hopefully with a board mounted in the car soon. Here's wishing. But certainly with the fuse box, let's see that thing going. Anyways, appreciate you guys. As always, we'll see you next time. Well, this is what you get when you hand-raise birds. They know who you are, and they want to talk to you. They just do what they do, because they're little creatures. They're not particularly smart. I mean, their brains are the size of peas. But they do love me, and they want to talk to me, and that's what they're doing. So, some people are a little annoyed by it. I know I got pretty annoyed today. Sometimes they're just way too bad when I record video. And he likes to try to dominate me. He's doing that ground picking thing where he's trying to act tough. But, yeah, these are my birds. I love them. They stay here. If you hate my videos because of my birds, you know, fuck off. You can leave. I don't need you. My birds will be here long after you're gone, right, birds? Yeah. I think most people usually find them kind of comical, but there's always those couple of jerks out there that want to say something nasty about them. But you know what? I love them. And even though they attack me and shit, they love me too. They actually snuggle up with me. They do. They're just doing what they do. They're just, you know, being dominant. There he is. He's quiet most of the time, except first thing in the morning. He woke me up today at 6:30, and I had only gone to bed at 3:30, so I didn't get a whole lot of sleep last night because of you, you dummy. I don't know why you woke up so early. Nobody else did, just you. And the ducks, they're not very obnoxious at all. No, they're not very obnoxious. I mean, they can be in the middle of the night to start yapping for no damn reason. I just shut their light off and then they stop. But these guys, when they start screaming, they don't stop unless you, yeah, see? They don't stop unless you like, physically manhandle them, or sometimes my spray bottle will get them. When they come in at night, I'll spray bottle them if they're noisy, and then they scream a couple times, and then they stop. Yeah, it's Biddy. Biddy knows the spray bottle. And I put just a little bit of vinegar in it, so that way when you get hit with it, it stings just a little bit if you get it in your eye. And yes, I tried it on myself, just like the police try mace, and I'll tell you what, it's nowhere near as strong as pepper spray. But they get just a little bit of vinegar, and it sucks, doesn't it? Yes, it does. He's gonna be a tough guy now. I'm not afraid of you, buddy. I'm not afraid of you. You're gonna bite the microphone. You hate that microphone. You do not like my camera at all. Alright, let's wrap this video up. I gotta get out tonight. It's actually Taco Tuesday tonight. Gonna go see Wild Bill. Go suck down some tacos. Have us a good evening. We're always up to something. Go see the ladies at the local taco joint. Are you about to do something to me? It looked like you were about to be aggressive. You don't do that to me very much. No, you don't. You're actually pretty good most of the time. He's gonna be a daddy. He and my Cheeky started making some eggs together. And they're starting to show some veins, so we might have some new babies coming up in the next month. I'll video on that soon. Alright. Thanks for watching, guys. Brum brum. Alright, we're testing the f***ing camera to see if it has f***ing audio this time, because last f***ing time it f***ed up my f***ing video.